In this video, we're going to learn how to determine the molecular formula of a gas using several concepts that we have already looked at in this chapter and previous chapters of this course. We're going to use the ideal gas law and some previous things like percent composition, calculating the empirical formula, and deriving the molecular formula from an empirical formula. To remind you of how to do that, you're going to use the molar mass of the molecular formula in order and divide by the molar mass of the empirical formula in order to determine from the empirical formula the coefficient that was used as the largest common denominator to simplify the molecular formula to the empirical formula. So keep in mind, this is an equation that we're going to use towards the end of the problem. So we've taken a look at how to use the ideal gas law, and if you need to review how percent composition, empirical formula, and molecular formula, go back to chapter 3 videos to review for those. So let's try a practice problem in order to find the molecular formula using the ideal gas law. So it says, what is the molecular formula of a compound that contains 39% carbon, 45% nitrogen, and 16% hydrogen if it happens to contain 0.157 grams of a compound that occupies 125 milliliters with a pressure of 99.5 kilopascals at 22 degrees C. So these are essentially two problems combined into one. One that is asking you to calculate molecular formula from percent composition, and you're going to have to go through empirical formula to do that. And the other one is you're going to use the ideal gas law in order to find out what the molecular mass or molar mass is of that substance given the pieces of information you have. And so we know that we've been given the grams, the temperature, the pressure, and the volume. We are going to need to use the R, or a specific R. We're going to need to determine what that is. And we're going to use the equation molar mass equals mass times universal gas constant times temperature divided by their pressure and volume. And this is just a derivative of the ideal gas law. So let's do that part first, and then we'll come back to the empirical formula component, and then we'll bring them together. So the mass we've been given is 0.157 grams. The temperature is 22 degrees C, which ends up being 295 Kelvin. The pressure we've been given is 99.5 kilopascals, and we can leave it in kilopascals because we have an R, 8.314, that has kilopascals as a unit in that. And the volume we were given is 125 milliliters. Well, that needs to be in liters, so we just move the decimal over 3 times to the left, and that's 0.125 liters. So now that we have all of those variables, let's go ahead and plug things in to this equation. I'm going to move that over just a little bit. So let's plug those in. 0.157 grams times 8.314 liters, kilopascals per mole Kelvin, times 295 Kelvin divided by 99.5 kilopascals times 0.125 liters. Make sure that your units cancel appropriately. Kilopascals cancel, liters cancel, Kelvin cancels, leaves you grams per mole, which is molar mass. So that's great. You did that correctly. And so when you do this, put this in your calculator. You're going to round this to 3 significant digits. This ends up being 31.0 grams per mole. So we know this is the molar mass of that substance. Now let's try to figure out a way for us to get to the formula, but we're going to use percent compositions to help us get there. So we have, and we're going to kind of move this down. We have 39% carbon and 45% nitrogen and 16% hydrogen. And so anytime you're given percent composition and you want to transition to moles essentially of each element and to determine what the subscript is in the empirical formula, you make an assumption that you have 100 grams, right? You're going to assume 100 grams of that substance, and then that will translate into grams from the percentage. So that means you'll have 39 grams of carbon, 45 grams of nitrogen, 16 grams of hydrogen. And what you're going to do is you're going to convert each one of those into moles. And to do that, for carbon, you're going to divide by carbon's atomic mass to equal 1 mole of carbon. And that's going to give you a value to 2 significant digits of 3.2 moles of carbon. For nitrogen, it's 14.01 grams of nitrogen equals 1 mole. And that translates to 2 sig figs of 3.2 moles of nitrogen. And for hydrogen, the atomic mass is 1.01 to 1 mole of hydrogen. That's a H right there. That equals, it ends up being 16 moles of H. Then we're going to divide how you determine, theoretically, these values that you see here should be these subscripts in the formula for carbon, nitrogen, and hydrogen, these values that go right here. Except for we only write those as whole numbers. So the easiest way to determine what the whole number ratio is divide by the smallest value of the three. So that is 3.2 that you would be using. And that gives you a whole number of 1 for carbon, 1 for nitrogen, and it turns out that value will be 5 for hydrogen. And so the numbers that would go here would be 1, 1, and 5, but of course, we don't write 1, so it's CnH5. Okay, so now that we have this empirical formula, there is a way for us to figure out what the molecular formula would be, and that's using this equation up here. So remember this guy right there. So let's figure out what the molar mass, we just calculated the molar mass of the molecular formula using the ideal gas law. Well, let's figure out what the molar mass is from the empirical formula that we just determined. So the empirical formula, you have 1 carbon, 1 nitrogen, and 5 hydrogens. I calculate that to be 31.07 grams per mole. And so for the molecular formula, we have that to be up here as 31.0 grams per mole. The empirical formula is 31.07 grams per mole. Well, that value ends up giving us an N value of 1. So that means we'll take 1 and multiply times each one of these subscripts that are here, and that'll give us the molecular formula. And 1 times any of those numbers, as you know, is going to be the same number. So CnH5 is the molecular formula of this substance. So this has been how you determine the molecular formula of a substance using the ideal gas law in conjunction with some previous concepts like percent composition, empirical formula, and molecular formula.